This video will guide you on how to set up the hardware of Mech-Eye 3D Laser Profiler for normal data acquisition. The hardware setup comprises mounting and wiring, of which the wiring involves 4 combinations based on different triggering methods. In this video, the combination of external plus encoder commonly used on site is taken as an example for introduction. Let's begin with the mounting part. Check the contents of the Laser Profiler package first. After opening the package, ensure that it contains a sensor head with its accessories, and a controller with its accessories. If any of the above items are missing or damaged, please contact Mech-Mind. Additionally, an IPC and a mounting plate are also necessary. Then, mount the Laser Profiler. First, mount the sensor head. It supports 2 mounting methods, side mounting and top mounting. To make sure the sensor head dissipates heat effectively, side mounting is recommended. Please refer to the documentation for specific mounting details. This video demonstrates the side mounting method. Attach the sensor head securely to the bracket. Second, mount the controller. Mount it securely in a suitable position according to the site requirements. This video will not demonstrate the process. Next, start wiring. First, connect the sensor head and the controller with the sensor head to controller cable. Insert the right angle connector of the cable into the sensor head, and the straight connector into the controller. After tightening the nut, a gap of about 2 mm is normal. Second, connect the IPC and controller with the controller Ethernet cable. Insert one end of the cable into the RJ45 port on the IPC, and the other end into the RJ45 port on the controller. Next, connect the controller and power supply with the controller DC power cable. The controller needs to be powered by 24-volt DC. Use the cable to connect the 24-volt terminal on the power supply to the positive terminal on the controller, 0-volt terminal to the negative terminal, and the ground terminal to PE terminal. After the above connection, supply power to the current unit. The power indicator light on the sensor head will light up. Subsequently, connect to the Laser Profiler and acquire data to confirm the valid connection. Open Mech-Eye Viewer. Select the Laser Profiler to be connected. Open the IP configuration dialog box. Make sure the IP address of the Laser Profiler is on the same subnet as that of the IPC. Click Apply. Then, click Connect. Turn on the profile mode. Click Capture once. The Laser Profiler can work normally. However, there is no clear profile. It means that the height of the sensor head is not within the reference distance and needs to be adjusted. Thus, click Capture Live in Mech-Eye Viewer and adjust the height at the same time. When the profile appears in the middle part of the field of view, indicating the optimal reference distance, fix the sensor head. Then, connect the external devices to the controller, triggering the Laser Profiler to acquire data. In this video, a photoelectric sensor is used as an external device to trigger data acquisition. In addition, the motion platform with an encoder is chosen to simulate the motion in the actual production line. Now let's operate the connection in detail. First, connect the controller and the differential encoder currently in use. The encoder works as the line scan trigger source. Connect the encoder A positive input to terminal number 37 of the controller's encoder signal terminals, the A negative input to terminal number 38, the B positive input to terminal number 39, and the B negative input to terminal number 40. Confirm successful connection of the encoder. Open the scan mode in Mech-Eye Viewer. Since the photoelectric sensor has not been connected yet, the data acquisition trigger source is set to software. Set line scan trigger source to encoder. Power up the motion platform, and click Capture once in Mech-Eye Viewer. With normal data acquisition, the encoder is successfully connected. If the data output is abnormal, use the Encoder and Input Signal Viewer tool to view the input signals from the encoder for troubleshooting. For specific troubleshooting steps, please refer to the documentation. Next, connect the photoelectric sensor to the controller. It's necessary to confirm the terminals used. There are 3 ways to control data acquisition with signals from an external device. All 3 ways control the start of data acquisition with the signal from the measure start terminal, but control the end of data acquisition differently. The most common method on site is to control data acquisition with the measure start terminal and the scan line count parameter. The video uses this method as an example to illustrate. Its terminal usage is as follows. First, terminal number 9 is level control enable single. Its logic level is set to low by default. Thus, there is no need for connection. Second, to trigger data acquisition, a switching signal is required on the measure start terminal. For this, connect terminal number 10 on the controller, and ensure that a low-level signal is input before data acquisition starts. Once a high-level signal is input, the software, and then the laser profiler will be triggered to start a round of data acquisition. Third, skip connecting terminal number 11 because scan line count is set to stop data acquisition. Finally, to form the signal circuit, it's essential to connect any one of the common terminals number 13 to 16. Having confirmed the terminals required, let's confirm how to wire. For the photoelectric sensor, its signal source type is PNP. Thus, just wire it as shown in the video. According to the provided wiring instructions, connect the photoelectric sensor and power supply. To receive a high-level signal, connect the signal output terminal on the photoelectric sensor to terminal number 10 on the controller. Following this, connect the negative terminal on the photoelectric sensor to the common terminal on the controller. Here, terminal number 16 is used as the common terminal. Confirm successful connection of the photoelectric sensor. In the scan mode, configure data acquisition trigger source as external. Power up the motion platform. Make sure there is no signal input to the photoelectric sensor, meaning that the detection area of the sensor should be clear of any objects. Click Capture once. No data is acquired. Then, manually block the sensor to simulate an input signal for the photoelectric sensor. The data can be obtained. This indicates that the photoelectric sensor is successfully connected. If the data acquisition fails, open the Encoder and Input Signal Viewer tool. Check the input signals from other external devices for troubleshooting. Our documentation provides detailed troubleshooting steps. Now, the hardware setup for the laser profiler is complete. You can refer to the documentation for more operations regarding the hardware setup of Mech-Eye 3D laser profiler.